The idea that our universe is a simulation gives the Big Bang theory a new meaning. In this case, the Big Bang does not only represent the physical beginning of the universe, but also the moment the simulation was initiated. This is why the cosmological theories of James Webb and new findings about the Big Bang are of great importance to physicists working on simulation theory. Just like when a computer simulation starts and the system begins to run, the Big Bang could represent the moment when the fundamental parameters of the simulation were defined and the process began. Even now, if you type universe simulation into the simplest search engine, you'll find dozens of simulations conducted even with our current level of technology, accompanied by numerous scientific publications. For example, the illustrious simulation managed to simulate 13.8 billion years, while the Millennium TNG project simulated the formation of 100 million galaxies. It's worth noting that all these simulations were performed without quantum computers. The fact that humanity, with relatively low computational power and knowledge, has started to model the universe has particularly led supporters of simulation theory to conclude that the Big Bang might be the start moment of the simulation. Analyses conducted on this topic, or even simple thought experiments, reveal remarkable similarities between the elements required to start a computer simulation and the Big Bang. In computer simulations, the initial conditions are predetermined. At the moment of the Big Bang, the universe appears to have had all its energy, matter distribution, and physical laws determined. Simulations often begin with maximum information density. All processes rely on this initial information. The Big Bang, which began with dense energy and matter, involved an evolutionary process based on information. Simulations operate with specific rules and algorithms, which become effective as the simulation progresses. The expansion and evolutionary processes of the universe resemble the dynamics of an advancing simulation. Physicist James Gates discovered structures resembling quantum-level error-correcting codes while working on supersymmetric theories. It has been suggested that such structures provide evidence that our universe might be a simulation. In summary, Gates implied, without explicitly stating, that the simulation we live in might receive updates at certain intervals and that some errors are corrected. Interestingly, this is almost identical to the Illustrious project releasing its new simulation model, Illustrious TNG, which corrected the errors in the initial simulation. Another approach directly associated with the Big Bang is Silas Bean's lattice hypothesis. Bean suggested that the universe might fundamentally behave like a simulation with a lattice structure. According to this hypothesis, the structure of the universe could reflect the basic characteristics of a system constrained by limited computational power. Bean and his team proposed that if the universe is a simulation, it might not consist of a continuous field, but instead be modeled with a lattice structure divided into small units. When we consider that all visualizations of space-time and general relativity are depicted as grids, and the Big Bang is thought to have started from a quantum-level small unit, it excites proponents of simulation theory even more. Computer simulations, when they reach a certain level of complexity or when system resources become insufficient, may experience performance issues, leading to the simulation's halt or restart. For instance, in climate modeling simulations, modeling atmospheric and oceanic processes at high resolution requires significant computational power and memory. In such simulations, long-term operations may lead to memory leaks or accumulated numerical errors that destabilize the simulation. This often necessitates restarting the simulation or optimizing system resources at regular intervals. At this point, it is possible to relate cyclical universe models to this phenomenon. Cyclical universe models propose that the universe continuously expands and contracts, with each cycle beginning with a Big Bang. It is argued that, as Silas Bean suggests, when the simulation's processing power is insufficient or errors accumulate without updates, the simulation is restarted, leading to cyclical universe models. The James Webb Space Telescope has made significant findings in cosmology by observing the early periods of the universe. Notably, it has detected that the first galaxies formed after the Big Bang are larger and brighter than expected. These findings have reignited theories suggesting the universe might be a simulation. If the universe is a simulation, such anomalies could result from the initial parameters or algorithms of the simulation. For example, if the universe is a simulation, inconsistencies could emerge due to updates made after the simulation start. This is akin to intervening in a computer simulation at a specific stage of its operation. When the simulation was initiated, early universe events, such as the formation of the first galaxies, were modeled in line with certain physical rules and initial conditions. If an update is made to the simulation later, the newly added parameters might conflict with early universe processes. For instance, if galaxies in the early universe are larger and brighter than expected, as observed by JWST, this could be explained by the effect of a subsequent update. The simulation theory approach, which likens the start of a computer to the Big Bang and the pressing of the reset button during a system freeze to cyclical universe models, is not widely accepted by the scientific community due to its unfalsifiable nature. Any attempt at falsification can be countered with the unresolvable argument that such efforts are themselves part of the simulation. As a result, within our current scientific framework, it is nearly impossible to disprove the existence of a simulation. However, this very situation might be sufficient to understand that the simulation exists.